Welcome back to Just Academic Mathematics YouTube channel where we make you a mathematics genius. Today we have a probability question, but not the normal probability theory that is known. This is what we call probability distribution question. It's out of 5,000 seed of cocoa planted, only 2 did not reach the age of 40 years. If 10,000 seeds are planted, find the probability that exactly 3 will not reach the age of 40 years, and so on and so on. Now, this is a probability distribution question, and basically we have 3 main probability distribution. We have what is called binomial probability distribution, Poisson probability distribution, and normal probability distribution. So you need to know the one you are to use. And from the question, because the expected value or the expected mean is less than 5, is a Poisson condition. Now, let me state the Poisson condition that we will check it. For Poisson distribution, the condition for you to use this states that the probability must be less than 0.1 and the expected mean or the expected value is less than or equal to 5, not more than 5. Preferably when it is less than 5, then it is said to be a Poisson distribution. So let's check what is our P. Our P here is what? First of all, our P is 2 over what? 2 over 500. That is our probability. Out of 500, out of 5,000 seeds of cocoa planted, only 2. So the P here now is 2 over 500. 5,000. And 2 divided by 5,000 will give us what? 0.0004, which is less than 0.1. That is our P. So what is our expected mean of our value there now? Our expected value is the number multiplied by the probability. If 1,000 seeds are planted, so this N here, 10,000 represent 10,000. So we have 10,000 multiplied by what? 0.0004. And when you multiply it, you have that the expected mean to be what? 4. 4 is less than 5 or is not more than 5. So Poisson distribution will work perfectly here. So all we now need to do is to answer the question. And therefore, the general formula states that probability of X is equals to the expected value or mean times e raised to the power of this x factorial. Now, this is an identity in mathematics. This one stands for 2.71828 ... But you can see it in the calculator. You can use it straight from the calculator in the second function. You can see it now, e raised to the power of x. So I don't need to be typing 2.7182 and so on. No, we'll just use it directly. Now, I've told you what this is already. So this one now stands for what? 4. You can see that is the number times the what? The probability, which is 4. So anywhere we see this expected mean or value, we put 4. X is the probability you are looking for. This one is known already, and this is X also. So for the first question that says exactly 3, that means probability of 3. So exactly 3 means probability of 3. S equals to 3. S equals to what? 3. S equals to 3. That is exactly 3. Is the expected value here is 4 raised to the power of x, 3. E raised to the power of minus what? 4 over what? x, which is what? 3 factorial. I'm still using x here. Here should be 3 now. X is 3. So that is all. You can just put the answer straight. So you can operate it separately to avoid confusion. You can operate it as 4 raised to the power of 3. That is 4 raised to the power of 3 multiplied by second function, that is this now, raised to the power of what? Minus 4 divided by 3 factorial, that is 6. 3 factorial is 6. But all of them are in the calculator there. So that will give me 0.19. Did they say we should approximate? They didn't say we should approximate to anything. So let's just write 0.1954 to 4-figure table. So this is the probability of obtaining exactly 3. This is the probability of obtaining exactly 3. So you can use calculator for this. You can use this. This one now, I've told you that it means what? 2.71828 and so on. But since you can, it's an irrational number anyway. Since you can't write it out completely, use it in the calculator. You will see it in the calculator. Raised to the power of, you use this minus here. This minus, so it's done. This here. Good. Use this minus 4 here, not this minus, not this one. It depends on the calculator you are using. So you use this minus 4. This is what I mean now. Let me show them, please. So this E now is in the second function, because here in the first function is in. We are looking for this other one. So second function is not on. Raised to the power of minus 4 equals to times 4 raised to the power of 3. 4 to the power of 3 equals to divide by 3 factorial. 3 second function factorial. That is 0.1954. Okay, that brings us to the B part. The B part say at most 3. At most 3. At most 3 will reach the age of what? 40 years. At most 3 will reach the age of 40 years. So probability of at most 3 means not more than 3. That is another way of saying probability of x is less than or equal to 3. Not more than 3. It's not greater than 3. And what does this mean? This means probability of s equals to 0 plus probability of s equals to 1 plus probability of s equals to 2 and plus probability of s equals to 3. The only one we have gotten now is the probability of s equals to 3. So we need to solve for these other ones. And we can squeeze them in here. For 0, we do the same thing. The expected value is still 4 raised to the power of x, 0. Then e raised to the power of minus what? 4 over 0 factorial. That is for this, for 0. Plus for 1, you have what again? 4 raised to the power of 1, e raised to the power of minus 4 over 1 factorial. For 2, you have 4 raised to the power of 2, e raised to the power of minus 4 over 2 factorial. And for 3, we have already solved for 3. But let's just repeat. We have 4 raised to the power of 3, e raised to the power of minus 4 over 3 factorial. So, what is our final answer? We operate each of them. So we have e raised to the power of minus 4 times 4 so let's take it again. I'm making mistake here. So this 4 raised to the power of 0 here is 1, of course. So this is just 0 factorial also means 1. So we are left with this now. That means we are left with only e raised to the power of minus 4, which is which is 0.0183 plus, let's take on the next one. This is 4. 4 raised to the power of 1 is 4. So that is, let's take on the other part first. E raised to the power of minus 4 times 4 divided by 1 factorial. 1 factorial is still 1, of course. So we're going to have 0.07 tere 0.07 tere plus 4 raised to the power of 2 is 16. So we'll take on that again, which is E raised to the power of minus 4 multiplied by 16 divided by 2 factorial, which will give me 0.1465. 0.1465 plus finally e raised to the power of minus 4 times 4 raised to the power of 3 divided by 3 factorial, which will give me 0.1954. So I will add them up to get the final answer. So that is 0.0183 plus 0.0733 plus 0.1465 plus, I don't even know why I started solving this again. We have solved it before. Plus 0.1954. So everything will give me 0.4335. That is the answer for the at most 3. Then finally, probability for at least 4. Probability for at least 4 means probability for x is greater than or equal to 4. That is from 4 and above. And what that means is 5, 6, 7, 8 to infinity. So what do we do is, this is something as 1 minus probability of x is less than or equal to what? 3. That means 1 minus, because if you add the two probabilities, you get 1. If you add from 3 to 0 and from 4 to infinite, you get 1. So 1 minus probability from 0 to 3. So the final answer is 1 minus 0.4335. So that will give us what? When we minus 1, so this one, the answer is 0.5665. This is the final answer for this. At most, at least 4 will reach the age of 40 years. So this is it. This is what we mean by Poisson probability distribution. It's just a simple thing, just for you to know how to operate it, and then that will be all. So make sure you watch it over and over again so that you will master it. And remember to subscribe. If you have not subscribed yet, subscribe and share this video. Thank you.